Okay, how's it going, guys? I hope everyone's doing good. So this is going to be my video. We're going to cover your assignment over the spring break. I've seen kind of the data. I know a lot of people have looked at it. I would like to hopefully be seeing more people looking at that. I don't know if a lot of people are just waiting for this video to come out. But this is going to be your step-by-step guide to walk you guys through these problems. Again, I want to make it clear, try not to just use these as just a way to get the answers in and then be done with it. The thing that's going to be really beneficial, that's why I'm giving it to you to prepare for the AP exam. So just take a look at these questions with me. We're starting with Unit 1, Progress Check, Free Response Question Part A. So that's where we'll be starting. So go ahead, if you guys should have that already out. If you don't have that already out, go ahead and open that up. On my screen, you'll be seeing what's up. So you'll be seeing the problem. I'll try to just go through that step by step so you'll see on my screen exactly where I'm at, and then I'll switch over to the hover cam and you guys can see what's going on there too. Okay, so let's get started. First question. Okay, no calculator allowed, so put your calculators away, you don't need them. Remember, this AP exam, you will have access to the calculators for every question, so that's not going to be ever an option, but it's good practice anyways. You don't want to rely on it. And a lot of times they'll create the test so you can't rely on it. It's not going to help you any. All right, so just we're not going to use it here. Okay, so you can read the directions here. Same directions for all these free response questions. You guys will be seeing enough of these before the test that you'll get used to what all that says, and we've gone over it before in class. And so let's just get right into it. The first part. Okay, so looking at a problem, hopefully you've already looked at it and already processed it. But what we have here is two different things. We have a graph. So you guys can see we have a graph of f. That's number one. Number two, we have a table of g. So a graph of f and a table with g. So the function g of x has a table. The function f has a graph. It says the graph of the function f is shown in the xy plane above. F has a discontinuity due to a vertical asymptote at x equals 6. And then let g be a function as continuous and increasing for all x. Values of g of x at selected values of x are shown in the table. Okay, so that's pretty much what I said. The only other piece of information was the fact that there's a vertical asymptote at 6. X equals 6 for the graph of f. So the first question asks us says using the graph of f and the table for g, estimate the limit. Okay, so right away we're looking at this. First of all, we have two different functions being used. We have f and we have g. We're finding the limit as x approaches 0 of f of x minus g of x. The easiest way I think about this is just using our laws of limits. So our limit laws. Okay, a lot of you guys I think are instinctively doing this without really, I guess classifying it as a limit law. But what we want to do here is this. So we're taking the limit. So this is 1a. We're taking the limit as x approaches 0. It's been a while since we really looked at limits. Let me get my camera focused here. So it's been a little bit of time since we really looked at limits. This is how we say them, right? Limit as x approaches 0. We want to find of f of x. And then minus, this is where we use our actual limit laws. The limit as x approaches 0 of g of x. That's a definition of a difference limit law. All right, so to estimate this value, let's split it up. Let's just focus solely on finding the limit as x approaches 0 of f and limit of x approaches 0 of g, and then we can just subtract those values. All right, so let's go back to the actual problem. The graph, really for both of these, all we got to do is just look at what's going on. Okay, so what we want to see here, and I don't know if you guys are actually able, I don't think you're actually able to see my mouse. But what you want to be doing, I'll try to be very specific with how I'm describing what you're seeing here, is I want you guys to look, to find the limit as x approaches 0 of f of x, look at this graph here of f. We want to figure out from the left and from the right. So if you follow that graph from the left and from the right, as it's getting closer and closer to x equals 0, what value is that approaching? So unfortunately, like I said, you guys can't see my mouse, but what you'll see is from the left and the right, you'll see that it's coming to like that triangle, like the point of a triangle. And that point is y equals 2. So the limit as x approaches 0 of f of x is 2. Again, looking from the right of 0 and the left of 0 of the graph of f. G is the same idea. We're looking at the left of 0 and the right of 0. So you guys can see it's actually that first row. So they give us that table of G, sorry. They give us the table of G. And you'll see that first row, the top row where it says X. We're looking at that and we're saying, okay, what values basically split up 0? And you can see it's negative 0.001 and 0.001. So we want to look at what's the Y value between those two. And you can tell that at the left of it, it's 1.999, and at the right of it, it's 2.001. So directly in the middle of that is 2. So the limit as x approaches 0 of g of x is also 2. So my final estimate then would be 0. All right, so going back to my hover cam, all you got is the limit as x approaches 0 of f is 2. Limit as x approaches 0 of g is 2. 2 minus 2 is 0. And that's all it is for 1a. All right, let's go for 1b. So let me go back to my screen here. Scrolling down, it says for each value, or for each of the values a equals 1, a equals 2, a equals 4, and a equals 6, we want to find the limit as x approaches a of f, or explain why the limit doesn't exist. All right, so we're splitting this up. Okay, so we have the limit as x approaches. Instead of a, we have 4 different a values. So the first one we'll do is 1. Okay, the second one we'll do is 2. The third one we'll do is 4. And the last one we'll do is 6. All right, so you can see on my camera here, my piece of paper, I just split it up like that. So we have the limit as x approaches 1 of f of x equals the limit as x approaches 2, limit as x approaches 4, and x approaches 6. So just starting off with that, I feel like that's a good way to separate these just so we can process them a little bit better. All right, what's kind of cool about this year's AP test is you are going to be able to use, if you're, if you like to color coordinate and you like to really differentiate your work like that, this is an exception. I don't know yet, I guess for sure, but I feel like this year you might be able to do that. I don't really know if they'll put any stipulations because you'll have access to different colored pencils and pens and stuff. So maybe if you're the type who likes that, you can see I split them up with colors, whatever works for you. Okay, so the question says for each values, find that limit. So let's just start at each one. So the limit as x approaches 1 of f of x. So looking back up here, let me scroll up to the graph because we're focused only on the graph. We don't care about the table, it's just the graph. All right, and so we want to look at that graph and find the limit as x approaches 1. So you just find the x value of 1, and you look at what's happening from the left and from the right. So everyone right now should be looking at x equals 1. You'll see that there's 2 different limits. From the left, that black line is approaching positive 1, and from the right, that black line is approaching 0. So the limits from the left and the right do not equal each other. Okay, if the limits from the left and the right do not equal each other, then that means the limit does not exist. All right, so how we write that is does not exist. Now the actual question says, use correct limit notation in your answers. Explain why it does not exist. So it's not enough just to say it does not exist. So what you want to say is approaches. So you can say that f of x approaches different values from left and right. So the limit of f as x approaches 1 of f of x does not exist because f of x approaches different values from the left and from the right. And even better, you could say different y values. Okay, f of x approaches different y values. And if we really wanted to get picky, left and right of x equals 1. You could say it's different values from left and right of x equals 1. So there's a couple ways. I think what I'm going to do is I might post the actual solution guides so you can see how these are graded. Or maybe just during one of our lectures, maybe our lecture on Monday, I'll talk about it. I don't know yet. So this could be the exact way to grade these. But you want to be very specific. Okay, you want to be specific, over detailed. Just say what you know. You know the definition of a limit is that it has to be equal from the left and from the right. in order for the limit to exist and to approach an actual value. So if it doesn't do that, that's your explanation of why it does not exist. All right, second one, limit as x approaches 2 of f of x. So let's go back to my graph here. So limit as x approaches 2. All right, this time it does approach. You'll notice that if you guys put your eyes on x equals 2, put a pencil there, whatever, you guys can see there's a hole there. There's a hole at x equals 2 on the graph. That's okay. Limit doesn't say that it's actually hitting that point. It just says, the limit is saying what is it approaching. So what y value is this graph approaching as x gets closer and closer to 2? And if you look at the left and the right, they're both approaching the same value. That value is 1. No explanation needed. That's just the answer. It's 1. Okay? Not too bad. Let's go to 4. 4 is the same idea. Okay, you'll see if you guys go use your eyes again, go to x equals 4. You'll see from the left and the right, it's kind of a weird graph. There's a linear part, and then it goes into like almost like a quadratic look. So from the left of 4, it just like dives straight down linearly. And then from the right of 4, it looks like it's got like a quadratic look to it. Okay? So that's weird. All right, it's weird, and it might not be differentiable, but that's not what the question's asking. The question just wants to know what's the limit. All we care about, whenever we're finding limit, we don't care if there's a hole there, we don't care if there's a point there. None of that matters. All we're looking at is just the line, the actual line of the function. And you'll see those lines from the left of 4 and to the right of 4 do approach the exact same value. And that value is -1. Y equals -1 is what that value approaches. All right, so back to my hover cam. That's all I'm putting for my answers. Just limit as x approaches 2 equals 1. Limit as x approaches 4 equals -1. Don't need an explanation. Doesn't tell you to explain what your answer is. It only explain if it does not exist. All right, and then the final portion we're looking at is when x approaches 6. So limit as f of x as x approaches 6. Now you look at 6. Again, that dot, I don't care about the dot. The dot there at x equals 6 does not matter to me at all. All I care about is the lines. The left of 6 and the right of 6. You'll see that these lines are both approaching, well, we don't know. Okay, we have no clue what they're approaching. We can assume that they're approaching infinity. We can assume that that limit as f of x, or as x approaches 6 of f of x equals infinity. We can make that assumption. However, my actual answer is, does not exist. And your explanation is because the limit approaches infinity from both sides. So the limit as x approaches 6 approaches infinity from both sides. That doesn't exist because we can't definitively say there's an answer. We don't know. And this graph also, if you guys look at the graph, it doesn't really give us enough information to know what the limit is for sure. For all we know, this graph could go to y equals 100 and they can meet at that point. We have no clue. Right? So there really is no way for us to actually confirm what this limit could be. So we make the assumption it's headed to infinity, which actually, let me rephrase that. I'm going to correct myself. I'm incorrect. They told us there's a vertical asymptote at 6. All right, so it actually changes our mindset. We know there's a vertical asymptote at 6. We know that the behavior of graphs to the left and right of vertical asymptotes are they follow the asymptote. Not necessarily always to positive infinity. Could be to negative infinity. But since they follow the asymptote, we do know that these are definitely going to be approaching infinity. Since that's not an actual value, we say the limit doesn't exist. And I don't know, you might be able to get away with just saying infinity and then doesn't exist. That might be a good enough explanation, but you got to always be careful. Check your work. Just double, just to be careful, put it like an actual written explanation. Never hurts. Okay. Let me look at 1C now. Got to look at my cameras to make sure I'm lined up for you guys. Okay. So 1C says, is f continuous at x equals -3? Again, we're just focused on f, so that's good. So the table with G, completely ignore. I don't care about it. I'm ignoring it. All I care about is the graph of f. Is f continuous at x equals -3? Let me scroll up. X equals -3. Bam, right there. Is it continuous there? That's the question. Now it's a little bit different. Now it's not asking for a limit. So continuity, I'm more concerned about the actual point. That's the difference between limits and continuity, right? Limits, you're just focused strictly on the graph. What is the behavior of the graph, not at the actual point. Continuity is completely dependent on actual points. We want to know, is every point actually continuous? When we think of continuous, the most basic definition of continuity is that if you were drawing a graph and you have to pick up your pencil, it would be discontinuous. If you can draw a graph that's completely smooth and you never have to lift your hand off the paper, then we know that it is continuous. All right, so that alone pretty much answers this question. If I look at this graph and I go to x equals -3, I notice at that point there's a hole. That means there's a jump in that curve. If I were to draw this curve, I have to skip over -3 because there's nothing there. So if I were to draw this picture, I would have to pick up my pencil, go past -3, and then keep going. Because of that, it's discontinuous. All right, so really this one, not too much work. I guess if you wanted to, the exact definition. So now you have your answer, right? So we know the answer is no. F is discontinuous at x equals 3. Or sorry, x equals -3. And let's be proper about this. Let's actually use the definition of continuity. And they might have said it, let me see if in the question. It says using correct notation, justify your answer. So I guess that's kind of your hint, using correct notation. So if you're asked to use notation, we can't just say, oh, we like use that basic idea that, oh, we picked up our pencil when we drew the graph. Okay, we gotta be a little bit more specific than that. Use actual math. So if you guys remember, the definition of continuity is this. The limit as x approaches a of f of x is equal to f of a. That's the actual definition of continuity. So my answer then would be no, f is discontinuous at x equals -3 because the limit as x approaches -3 of f of x is equal to, if you guys actually look, the limit was equal to, so let me go back to my screen, the limit was equal to -1. From the left and from the right, the lines are approaching -1. But f of -3 is equal to that filled in dot. So you guys can see at x equals -3, at 2 there is a filled in dot. That's what the point is actually defined as. So f of -3 is equal to 2. So because the limit is equal to -1, and the actual point is defined at 2, these are not equal. I'm trying to go through this a little quick. This isn't like a perfect answer. Like obviously you want to be specific with your words. So whenever you guys are answering these questions, be as specific as possible, as detailed as you can with your answers. This is pretty vague, but since you're listening to my words, you won't have that luxury on the AP exam. But since I can teach you and you can just hear my words, you understand what I'm saying here. I wrote down the definition of continuity. This is proving that this does not remain true. F of a does not equal the limit. All right, so because of that, it's not continuous. So that's the correct answer you want to bring to the table. You want to use the idea that, okay, I can at least get partial points because I can confirm it's not continuous. So there's a couple points just right there. To get your full credit, though, you want to use the notation of continuity. Super, super important skill to have for the AP exam. Okay, last question. Now this one is kind of a little bit of a curveball. It seems like it might be difficult, and it turns out to be very basic. So it says, write a difference quotient that best approximates the instantaneous rate of change. Really, really, really important. Okay, they don't mention anything about limits. Okay, anything about limits, anything about difference quotients and limits. They say approximates, that's a big word, approximates instantaneous rate of change. Whenever we're approximating instantaneous rate of change, we are going to take an average rate of change, the closest possible average rate of change. That's what we do. So if you guys remember when we first started learning about limits and learning about instantaneous rates of change and average rates of change, we would always take the average rate of change that gets closer and closer to a point. We call that the secant line, the slope of the secant line, getting closer and closer to the actual tangent line. And that was our best approximation of the instantaneous rate of change. So that's all we're doing. All right. This question specifically is working with G. So let's, F, don't care. Just going to focus on this table of G. The question was saying as x approaches 0. So what is the best way to approximate the instantaneous rate of change as x approaches 0, right? So looking at this table, you want to find where is x approaching 0. Well, it's right in the middle. It's at negative 0.001 and 0.001. So to find a difference quotient, what we want to do is we want to find the average rate of change. So we take g of 0.001 minus g of negative 0.001 divided by 0.001 minus negative 0.001. All right, sorry, I keep forgetting. You probably have to see my work. All right, so this is the difference quotient we would write. G of 0.001 minus G of negative 0.001 divided by 0.001 minus negative 0.001. All right, and that's y2 minus y1 over x2 minus x1. It's slope. It's something you guys have been doing since Algebra 1. Okay? That's not an instantaneous rate of change. That's not what we use to find one, but that's the best way we can do it. That's because all the information that's given to us, that's all we got. So to get an estimate, we just take the closest possible secant line, which means we're going to take the closest possible x values. All right, and we're going to actually plug in, because in the table they gave us what these values are. They told us g of 0.001 was 2.001 and g of negative 0.001 was 1.999. All right, and I'm just going to leave the denominator like that. Obviously, I think you guys can add that, but what's the point? You're risking possibly getting points off. So remember, guys, we don't have to simplify our work. Don't need to do it. You'll have your calculator, okay, so that'll help, but no point. Just end it here. What's important is you no longer have function values. So if you know what these are, make sure you replace them, because you do. They give it to us in the table. But then when you get here, I don't need an actual answer. That's it. That's all I want. That is your answer. Yes, there's a value, but we don't care. Okay, AP is not going to grade you on that, so just keep it like that. Call it a day. All right, and that's Unit 1, Progress Check, FRQ Part A. That's the first question. All right, let's look at the second question. Go down here. So this is 2A. All right. Okay, so here's the question. It says, let f be the function defined by f of x equals ax squared plus bx plus 2 divided by 2x squared minus 8, where a and b are constants. The graph of f has a horizontal asymptote at y equals 3, and f has a removable discontinuity at x equals 2. All right, so what I like to do usually, like if you would see my work on this, I would write all that stuff. I don't know why. I would write it all back down on my paper. For me, it helps me organize instead of having to constantly look back at the problem. So maybe that'll help you guys if you want to right now. Maybe write those down. Write each of those pieces down so you have it and you can reference it. But let's just look right at it. And A looks pretty harmless. It ends up being a little bit more complicated than it looks. So all it says is show that A equals 6 and B equals negative 13. All right, that's good. Good to know. What we have to use is this idea of the information they give us that f has a horizontal asymptote at 3 and a removable discontinuity at 2. So first things first, how do we find a horizontal asymptote? That's your first piece of information you know. And to find a horizontal asymptote, you need to take a limit as x approaches infinity. So we have the limit as x approaches infinity of our f of x, which ends up being ax squared plus bx plus 2 divided by 2x squared minus 8. If we know the horizontal asymptote has to be at y equals 3, that means that limit has to be 3. The behavior of graphs along horizontal asymptotes is as x approaches negative and positive infinity, they will follow the horizontal asymptote. All right, so we know that it has to be equal to 3. This function has to approach 3 as x goes to infinity. So we can set up this equation, which is pretty good for us. Now, you don't have to necessarily show this step because we do have a shortcut, if you guys remember. So I'm gonna use the shortcut, but I'm going to tell you just as a reminder how we got there. When we first started learning these guys, when you first started learning about horizontal asymptotes, we would divide everything by the biggest exponent in the denominator. So we would have divided this entire fraction by x squared. So you would have basically gotten a plus b over x plus 2 over x squared divided by 2 minus 8 over x squared. And the reason we did that was because then we could see that once we had plugged in the limit, when we actually evaluated all those, basically everything went to 0. And all you would be left with is a over 2. I know I didn't write that down. Maybe you're visualizing, just a reminder. The biggest thing and what we've focused on for a large majority of the year has been the shortcut. This idea that if you have the same exponent values, meaning that the highest exponent is 2 for numerator and denominator, the shortcut to find this limit is you just take the coefficients up front. So that proportion, a divided by 2. So that's all we're left with. The limit as x approaches infinity of that equals a over 2. That's the proportion of the coefficients. Okay, which makes our life pretty easy, right? Because then multiply by 2, a equals 6, check mark. Bam, just prove that a does in fact equal 6. All right, next thing we want to figure out is use this idea of a removable discontinuity. So in order for there to be a removable discontinuity, we have to find the points where the numerator and the denominator are both equal to 0. I'm going to use red. I'll just cut that in half. We want to find where the numerator and denominator, what value of x makes those both equal to 0. All right, so let's do that. Let's start with just the denominator because it looks pretty harmless. So the denominator is 2x squared minus 8. We have to set that equal to 0. Okay, do some math. We get 2x squared equals 8, x squared equals 4, x equals plus or minus 2. So this is just strictly the denominator. That's when those are the x values the denominator is equal to 0. Now, if I were to plug in, you're going to see this actually later in the problem, so I'm not going to worry about it too much right now, but it would help. If I were to plug in negative 2, I would actually see that the numerator and denominator would not both be equal to 0 at negative 2. Again, I have to figure out where the numerator is equal to 0, what x value. Okay, I am going to say that if I'm telling you right now, because I just want to save a little bit of time, if I were to plug in negative 2 back into the original equation with a and b replaced, it would not be equal. So I'm going to focus strictly on positive 2. So I'm going to take the numerator, which the numerator is going to be a is 6, all right, x squared, so instead of x we're going to use 2 squared, plus, we don't know what b is, we're trying to prove b. We know again x is 2, plus 2 is equal to 0. So again, I'm just focusing on just the numerator here. I just took that numerator of the original function, I'm just replacing x with 2 and a with 6. All right, doing some math, I get 24 plus 2b plus 2 equals 0, and I get b equals negative 13. So there we go, another check mark. So that's my proof that a and b are 6 and negative 13. All right, I'm going to flip the page here. Let's go back to my screen. And let's look at number B. Let's look at number B. Look at letter B. All right, letter B says to make f continuous at x equals 2, f of 2 should be defined as what? This is what we call a beautiful removable discontinuity. Hopefully you guys remember that a little bit. Removable discontinuities. All right, we want to figure out what value at f of 2 should be defined, okay, in order to remove that discontinuity. If you guys remember, like I said, the removable discontinuity is because at x equals 2, the numerator and denominator both equal 0. So 0 over 0 is going to be undefined, no good for us. So we want to figure out what should f of 2 be defined as to make it continuous. All right, and so let's look at how we do that. Definition of continuity. If you guys remember, we talked about this in the first problem, right? The limit as x approaches. In this case, we're focused strictly on the point 2. So as x approaches 2, of f of x needs to be equal to f of 2. That's the only way that this is continuous. All right, so what we're looking for then is the limit as x approaches 2 of 6x squared minus 13x plus 2 divided by 2x squared minus 8. That's going to be equal to f of 2. All I did was plug in f of x. Now, but remember, now we proved a and b were 6 and negative 13, so I can replace those values. I'm good to do that now. All right. If you guys direct substitute, remember, you should always be thinking direct substitution. So right now in my head, I'm like, oh, let me direct substitute x equals 2. If I do that, I get 0 over 0. No good. However, we can't give up, guys. Remember, that's just called indeterminate. That's an indeterminate form. That doesn't mean that we can't do anything with it. It just means that we're going to have to try something else. All right, and so what we want to try here is factoring. Okay, we can factor the numerator and denominator and see what cancels. All right, so I'm gonna just skip the factoring part because I'm gonna assume that you guys are okay with factoring. If you're not, please message me or something. I'll be more than happy to maybe do that for you, or you can look it up online, obviously. Just to save some time, I'm not gonna actually factor. What you're gonna get is when you factor the numerator. So you'll have the limit as x approaches 2 of 6x minus 1 times x minus 2. And the denominator, it's pretty easy to factor. You're going to factor first a 2 out. And you're going to get, if you were to factor out a 2, you're going to get x squared minus 4. And you can split up x squared minus 4 as x plus 2 times x minus 2. So again, that step there, the step from 2 to 3, we just factor. All right. Now, what you'll notice is we can cancel. That's what we're looking for. That's the point of factoring, to cancel something out. So what I'm left with is the limit as x approaches 2 of 6x minus 1 divided by 2 times x plus 2. That's equal to f of 2. And then you'd use direct substitution, and you get 11 divided by 8 equals f of 2. So the point needs to be defined at 11/8 in order for this to be a continuous function. The y value must be 11/8 at 2. Again, direct substitution to get there. All right, still rolling. 2c. So back to my screen here. At what value of x does f have a discontinuity due to a vertical asymptote? All right, now we're kind of bringing this full circle. If we are looking at a vertical asymptote, if we want to know where there is a vertical asymptote, that's when the denominator equals 0, but the numerator does not equal 0. We actually already did the work for this. Okay, we know the denominator is equal. So we know that the denominator is equal to 0 at x equals plus or minus 2. So if you guys want, I don't know if you need to write this, but that was found in part A. We found that little detail in part A. So you don't need to show any work for that, you already found that. So my answer then becomes this. only at x equals -2, so I'm going to circle that because that's my answer, does the numerator not equal 0? So there's a vertical asymptote there. I know I abbreviated some stuff again. I'm more concerned that you're hearing me voice out the answers, and then you guys can write that, because I'm actually curious. Even if you are listening to this and going through the answers with me and doing the work as with me, I would love to see everyone's, the way that you would present your answer to submit. I want to see how you guys would word it. So I'm being a little bit vague, not too crazy specific with my answers, because I would like to see exactly how you guys would formulate it. But that's the gist of it, all right? We know that it's 0. We know that there's a vertical asymptote potentially at x equals plus or minus 2. We know that at positive 2, it's actually a hole. We know that it's a removable discontinuity, which means that the only other spot would be at -2. All right, and that's the first question, or the first progress check. Unit 1, progress check, part A. All right, so as I'm going through this, guys, just remember, if you didn't do part B yet, go ahead and try that. Maybe some of this stuff refreshed your memories. Maybe you'll be able to get through part B a little bit quicker. So pause the video, go attempt that before I start on the next one. Highly recommend that. I think it'll be very beneficial to you. If you've already tried it, already looked at it, and you thought, you know, I'm still really confused, Mr. Harris, or I have a couple questions, can we just go over them? All right, you're fine. Let's watch. You can watch this video and continue it. I really do recommend, though, you try. Okay, so this is going to be one question. This is FRQ. Put it in my paper. Part B. So Unit 1, FRQ, Part B. All right, question number 1. Again, no calculators allowed. We're not going to use a calculator, but you probably will have, well, no, you will have access for your AP test. So always useful, but we're not going to use it. So the question is given to us. It gives us piecewise. Remember, this is what we call piecewise. It's got all these little pieces and parts. It says the number of fish in a pond at time t years is modeled by the function n. So n is the number of fish. F, or f of t, is just some continuous function. Right now, we're not concerned what it is. Maybe later in the problem we'll be given what it is. Okay, but this is the information we have. We do know f is a continuous function such that f of 0 is equal to 80. Okay, so we know f of 0 equals 80. That could be useful. We'll see. Part A says find the limit as t approaches infinity of n of t. Explain the meaning of that limit in the context of the problem. So this is kind of like 2 questions in one. Let's just first start with this. The limit as t approaches infinity. So I'm going to go back to my hover cam. That's what we're going to start with. Okay, before I can process what it is in the context, we'll wait for later. That's all I want to start with. So in order to find this, we need to actually get a limit. We need the function. We can't take a limit of nothing. We need a limit of a function. So inside here, I should have a function. So let's actually go back to the piecewise. Let me show you guys back to my screen. The piecewise function. Right now I'm going to ask you, what part of this function is concerned when, or which part of this function is true when t approaches infinity? In other words, basically what we have is 3 different functions within one. That's the definition of a piecewise, right? Multiple functions within one function. We want to know which of these 3 functions is, is being used for when t is approaching infinity. Okay, and the answer to that is the last one, because the last one is the function that's on the graph when t is greater than or equal to 8, which obviously, right, infinity is greater than or equal to 8. So we want to use this function, the very bottom function at the, of the piecewise. So back to my work, I'm going to copy that in. So that function is, I'm going to reverse it, so it's actually 80t plus 200. You guys will see why I'm doing that in a second. And I think they purposefully did that to try to mess you up in the question. So I'm just going to rewrite it so the variable's out front. Maybe you're thinking to yourself, Mr. Harris, why are you doing that? And then some of you are like, oh, I know why he's doing that. And the answer of why I'm doing that is because we can use my rule. of that I used last problem, right? The rule being that the limit as t approaches infinity, we're looking at horizontal asymptotes. Okay, to find a horizontal asymptote, if you have matching highest degree variables, which I do, right? T and t are my highest degrees, I can just take the coefficients out front. That proportion. So 80 divided by 0.05. That's my answer. That's the limit. And if this was a question of, if this is a question in your AP exam, I would hope you would keep it like that. But we have our calculators for these. You could do this, right? I'd probably just change this into a fraction, 0.05. I'd change it as like 5 over 100 and then solve it, try to simplify it down. It's not like the easiest thing. But we end up getting 1600. I'm just going to keep that in case we need it later. So now the question is then, we got the first part of the question. Next part, it says explain the meaning of that limit. So what does that limit mean? Well, we know the first part is as time t increases. That's the first part of the question. As time t increases. That's what the limit as t approaches infinity means. It means as t is getting bigger and bigger. In other words, as time is getting bigger and bigger. If we're taking the limit of the function, well, the function represents the number of fish in the pond. Okay, so we got the limit part, we got the actual function, what that's telling you. Now let's actually go into what the answer is giving us. We're saying that as time t increases, the number of fish in the pond, big word here, approaches, limits are approaching values, right? And the actual answer is what it's approaching. It's approaching 1,600 fish. So as time t increases, the number of fish in the pond approaches 1,600 fish. It doesn't mean it equals 1,600 fish at infinity time, right? That's not infinity time isn't a real thing. But it's just saying as time gets bigger and bigger, it looks like there's a threshold. The number of fish in the pond is not going to get any bigger than 1,600. That's my horizontal asymptote. It's cutting it off. It's saying, nope. Pond's not going to support any more of this fish. You're toast. Too bad. Suck it up. That's what this is saying. 1,600 is the max. That's all we can hold. Just like a restaurant, right? Maximum occupancy. Can't have any more. There's a fire hazard. I don't think there's going to be a fire hazard in a pond. You guys can do the physics on that, but chemistry, I guess, really. But that's your answer. 1,600. All right. Let's look at 1B. So looking back at the question for 1B, it says, is the function n continuous at t equals 8? Justify your answer. Well, guys, we're using our favorite rule or favorite concept, which is the definition of continuity. This is going to be a little bit different, and here's why. General functions that are just one function, all we have to do is just take the limit as it approaches that value, and then set it equal to the actual defined value. This is different only because the limit is two different. We have to determine what the limit is, because the functions are different on two different sides of our points. So what I'm trying to say is at t equals 8, notice we can't just use one of these functions. Meaning the second and the third one. I have to find the limit of both of them. Okay, the one on the left. So we'll start with that one. Let me go back to my hover cam. Is saying the limit as t approaches 8 from the left. We have to first determine that, which is the function 25t plus 150. That has to be equal to the limit as t approaches 8 from the right, which is 80t plus 200 divided by 0.05 t plus 2. All right, so the definition of continuity means the limit has to equal the actual point. All right, so we got that part. We got the limits from the left and the right, because that's going to give us the overall limit. Those have to be equal, or the limit doesn't exist. Again, limits from the left and right have to be equal, or the limit doesn't exist. So we have to check out both. And those have to be equal to n of 8 in order for it to be continuous. All right, and these aren't bad. Okay, so what we're doing is direct substitution for all of these. So you first direct substitute 8 into this, and you get 350. Direct substitute 8 into here. Again, I'm not going to spend time doing that. You have this problem, you didn't have your calculator. For the actual one, you will. So I'm not really like super concerned about going through the mental math on that. It would take a little bit of fraction changing is what my recommendation would be. So if you would like to practice that, you can do that in your own time. I'm just going to tell you what it would be if you put in your calculator, direct substituting. You get 350. N of 8. How do we decide what we're using for N of 8? Well, if you go back to the actual piecewise function, if you look at the very bottom function, it's for t is greater than or equal to 8. Greater than or equal to 8. So we have to use the last function, which obviously, right, would just be equal to whatever we just found, which we found was 350. So N of 8 is equal to that limit. So 350 equals 350, which equals 350. So your final answer is yes, N is continuous at t equals 8. So because the limit is equal to the point. Beautiful, beautiful, beautiful. All right, let's go to 1C. Back to my screen here. It says the function n is continuous at t equals 6. Is there a time t for 0 to 6 at which n of t equals 250? Justify your answer. All right, so we know the function n is continuous at t equals 6. We also know it's continuous at t equals 0. We want to know, so let's recap. We can determine then it is continuous. It's got to be continuous on that interval. If f of t is continuous from 0, so if you guys look back up here, right, the piecewise function, the function f is defined from 0 to 6. It tells us in the actual question here, it says n is defined above where f is a continuous function. So we know it's continuous, which is really important. I keep saying that, but it's super important because it tells us we can actually use a theorem. That theorem is called the intermediate value theorem. We're given n of 0. Okay, n of 0 is the same thing as f of 0, right? Because n is defined as f from 0 to 6. So if f of 0 is equal to 80, again, given to us at the beginning of the problem, then we know n of 0 is also equal to 80. So back to my hover cam, you guys can see, I'm just saying n of 0 equals 80. So when there is, at time 0, there's 80 fish in the pond, is what that's saying. Okay, I also know what n of 6 is. Mr. Harris, why are you finding that? Well, it gives me this interval. I want to know what we started with and what we ended with in that time interval. It gives me the interval 0 to 6. Well, where is 6 defined? At which function? Well, you can see 6 is defined at the second function, 25t plus 150, because that's when 6 is less than or equal to t. So we plug in 6 into that second function, and we get 300. So we take that second function where 6 is existent, and we plug in 6 into that, and we get 300. The actual question says, is there a time t from 0 to 6 where n of t equals 250? This is where we use the intermediate value theorem, because we know to be a fact that 80 is less than 250, which is less than 300. We know that's true. Okay, so we know at the beginning of the interval it's 80, the end of the interval it's 300. We know 250 would fit right in between those. So now we got all the pieces of our puzzle. We can actually write our answer. So what I'm going to write is by definition of, you guys would write out intermediate value theorem. There must be a value of t between 0 and 6 where n of t is equal to 250. Now, really quickly, I want you to think about this. I'm missing one important piece. One important piece to this question I am missing. And that important piece is that I need to state it's continuous. I know it gave it to me. I know it's implied because we can read the question and it tells us that. But what I would recommend doing is somewhere in that answer or somewhere before, specify n of t is continuous from 0 to 6. Guess we can put less than or equal to as well. So that mixed with this. So like basically everything in this box is all the proof you need where you can use intermediate value theorem. All right. So again, you guys can word that how you want to word it. I'm curious to see people's answers to that. That's generally how you'd want to answer this question, intermediate value theorem. I guess the hard part is deciding when to use it, guys. Get used to this type of question. It's giving you an interval and it's asking for a value of n on that interval. It can't happen. That's a really good hint that you're using intermediate values. If you guys want to go back, go ahead and go back in your notes. Check some intermediate value theorem notes. It's been a while. The concept is basically if I were to draw a graph and I were to never pick up my pencil, where I started and where I ended, I have to hit every point in between. Because I would have to pick up my pencil to avoid any points in between those, right? So from 0 to 80, I would have to fill every single point in on my graph. That's what the intermediate value theorem is saying. All right, I know I'm flying through. Last one, though. So go ahead and open up Unit 2, Progress Check, Part A. Right, make sure my notebook's all good. Okay, this one you can use your calculator on. Again, obviously you'll always be able to use your calculator in this year's AP exam, but just so you guys know, if you were to use this, just know you can use it. There's a lot going on in this question. So they give you a graph of f. They say let f be continuous. We can tell it's continuous just by looking at it. It's defined from -1 to 8, great. It also says let g and h be the functions defined. Let me scroll down a little bit. Let g and h be the functions defined by g of x equals the square root of x squared minus x plus 3. H of x equals 5 e to the x minus 9 sine x. All right, so we got 3 functions, people. We got f, we got g, we got h. If you would like to, on your piece of paper, write each of those down separately so you can kind of organize them if you prefer. Part A says the function k, oh great, that's happy us, we get a 4th function, right? K of x is defined by k of x equals f of x times g of x. What we want to find is k prime of 0. Well, before I can find k prime of 0, I first need to find k prime of x. So I'm given k of x equals that. I need to find k prime. Okay, not so bad. If I'm taking the derivative of a product of functions, I use product rule. Exactly, product rule. So I'm going to use product rule, where you have f prime of x times g of x plus g prime of x times f of x. Reminder, guys, product rule, the order doesn't matter because you're adding them. Just make sure that one derivative is with the opposite function, and then the other derivative is with the other function. So like however you set this up, not a huge concern, just be consistent. Make sure that you have a g of x times an f prime, a g prime times an f. Okay, you don't have to put this step, but just to make, I don't know, maybe this will be maybe some people like to look at it this way. If I'm finding k prime is 0, I'm replacing all my f's with, or all my x's with zeros. And now the way I'm going to organize my work is I'm going to actually try to find each of these values. So I'm going to actually label each of them so I have them. All right, so f of 0, I'm just going to use the graph. So let's go back to the screen. Okay, f of 0, you just look at the graph. All right, at x equals 0, what is the graph y value? It's 3. It's pretty easy, right? So my answer for f of 0 is 3. F prime of 0, a little bit more challenging. Let's go back to my screen here. F prime of 0. What is f prime saying? Well, why is my screen gray? Whatever, you guys can see. Okay. What is f prime saying? The derivative of a function is the slope of a function at a point. The derivative of a function is the slope of the tangent line at a point. Well, on a linear function, which this is a graph of a piecewise linear functions. On a linear function, the slope at a point is the slope of the entire line. So if you guys look at x equals 0, all we're looking for is what's the slope of that line, right? Because at x equals 0, it's just one constant line up until x equals 2. What's the slope of that line? So you guys can do rise over run, right? We passed 10th grade. Rise over run, so you're going to go up 1, 2 over 1. Up 2 over 1 is 2 over 1, which is 2. So the slope at the point x equals 0 is 2. Not so bad. Don't even really need to show any work. All right, g of 0, we're given the function. We're given what g of x is. G of x equals x squared minus x plus 3, the square root of that. So you just plug in 0. 0 minus 0 is 0 plus 3. So what you end up getting for g of 0 is going to be the square root of 3. Just plugging it back into the function. G prime of 0 is going to be a little bit annoying. Okay, now we are very lucky because we can use our calculators. So let me see here. Bam. Got my calculator. Hopefully you guys can see it. Go to math. If you guys have a different calculator, make sure you are researching before the exam how to use a derivative. If you can't use it, because we're going to have access to the internet for the AP exam, I will give you maybe some resources you guys can find derivatives using. So maybe I can give you like a website or something where you can use, you guys probably already know if we're going to be honest with ourselves. But if you do need that assistance, let me know. So for those using your calculator, you scroll down to n deriv. It's going to be with respect to x, so d dx. You're going to type in g of x, which is the square root of x squared minus x plus 3. And x is going to be at the point, we're looking for g prime of 0, so x is going to be equal to 0. Press enter, and you get that value. Now, you guys can store this. I know probably a lot of you store those values. Try to keep it exact. So just for the sake of the actual question, I'm just going to write out like a ton of decimals. I got to be honest, this is a bad habit I use. I don't recommend it. I'm not recommending it. This is just what I do. I don't know why, just how my brain works. If you guys want to, just catalog it into your calculator, like make it, assign it as A, alpha A or something, whatever you want to do. Just try to keep it exact. That's the point of my making. Make it exact. So I got all my pieces. All I got to do is plug these back in. So I'm going to get f prime of 0 is 2. G of 0 is square root of 3. G prime of 0 is that big thing. And I'm just going to keep it as negative 0.288. I know I'm being lazy, but, I've been doing this for about an hour now, and I already wrote down what it is. You guys can, do with that what you want. And then going to be times 3. So don't put it like that. Put the whole entire number in. Then you're going to put all that in your calculator. And you actually can keep it like this. Again, don't do 0.288. I would maybe go, probably, if anything, do 0.289, or maybe just go a couple more decimals. This is actually a viable answer. So remember, AP will take this. Just keep it like that. That's your answer. Good job. You guys did great. All right, 100%. If you wanted to, though, I don't know, some people are anxious about it, and you have your calculator, so if you're confident enough, this would be what your answer would be simplified. Again, though, just keep it like this. You're clear. You're done. You're correct. They will give that 100%. All right, that was 1A. Just basically product rule and then using your calculator. Okay, scrolling down to B. The function m is defined by, so let me go to, yeah, I'll do this page. Should be fine. So m is defined by f of x divided by 2g of x. And we want to find m prime of 5. Okay, well, we got m of x. In order to find m prime of 5, it's the exact same thing, but first we need m prime of x. All right, guys, this is quotient rule. So last problem was product rule. This time we're using quotient rule. So if you remember trusty old low-de high. So low times the derivative of high minus high times the derivative of low, all divided by low squared. Low-de high minus high-de low. Okay. Again, this step isn't necessary, but if you would like, we're actually looking for m prime of 5. So that means we're looking for g of 5 times f prime of 5 minus f of 5 times 2g prime of 5, all divided by 2g of 5 squared. All my 5s look like s's. I promise you there are no s's in this problem. They're all 5s. Believe me. Okay, and we're going to use the same idea here. We want to find f of 5, f prime of 5, g of 5, and g prime of 5. All right, can't see the bottom one. Hold on. Yeah, that's better. Okay, so f of 5, just looking at the graph. You go back to your screen, you look at the graph. At 5, what value is it on? Well, it's on 5. Okay, not too bad. I'll trust you guys can look at the graph with your eyeballs. F prime of 5, just like before, last problem, we're just looking at that graph. Okay, so I'll actually go to the screen here. We're looking at this graph, and we go to x equals 5. Now we'll see we're using a different line, so the slope's going to be different, but same thing, rise over run. In this case, you're going to get the rise over run is negative 2 divided by 3. Okay, so the slope of that line is negative 2/3. G of 5, use your calculator, plug it into the original g of x equation, and you get the square root of 23. G prime of 5, same thing I just did in your calculator, do the exact same thing. So you actually probably can just go like, let me move this down. So you can probably just go back to your history, click enter up there, and just switch 0 with 5. All right, so you don't have to do all that work again. You get 0.933. Or no, 0.93831. We'll just put that. 0.93831. Okay, and your final answer then, the final answer you want to write would just be m prime of 5 is equal to 2 times the square root of 23, times negative 2/3 minus 5 times 2 times 0.93831, whoops, all divided by 2 times g of 5, so 2 square root of 23 squared. That's your final answer. No need to simplify, just keep it like that. I know that's really messy. I apologize. I didn't know how to get to the bottom of the page like that. Horribly messy. You guys would write that way neater. But all I did was I just plugged in these values I had, right? So instead of g of 5, I'm replacing square root of 23. Instead of f prime of 5, I'm replacing negative 2/3. This is how I'm solving these problems. You don't have to do it this way. I know I do a lot of extra steps that may not be needed. Some of this stuff you can simplify. You can write it as fractions. You can write it as square roots, however you chose to do it. What's important, though, is don't do any more work from here. There's a lot of errors. Last problem wasn't as bad. This problem, there's a ton of errors that can happen in your calculators right here. You guys can plug this in very easily and correctly and miss points because you try to go a step further. Keep it like this. Keep it as generic as possible. The difference between like when you know to stop, when you know that you're good enough, is when all of your function values have been substituted for. So like if you would have got here and then stopped, you would not have gotten full credit. But since I replaced g of 5, f prime, g prime, and g, I replaced all of those. Because I did that, then I'm good. I know I'm good to stop. It's all values, all numbers. If anyone's curious, you end up getting negative 0.171. All right, guys, YouTube video almost over. Last problem. Let me get my hover cam back, looking good. All right, 1C. This question says, find the value of x for negative 1 to 2 such that f prime is equal to h prime. All right, well, f prime. That's what we want to find first. So we want to find that f prime of x is equal to h prime of x from negative 1 to 2. Let's first just find what is f prime of x equal to from, or sorry, let me just put 4, negative 1 is less than x, which is less than 2. What does that equal? And we actually know what that is. All right, because remember, the derivative is just telling us the slope. So if we go back to the graph, well, from negative 1 to 2, it's just one line. It's a linear function. So to find what the derivative is, we just find the slope of that linear function, which we've already done, right? We already did that. We found that was 2. We did that in part A. So we know that f prime of x is always going to be 2, because the slope at every single instant always will be 2, because it's a linear function. So that part's easy, right? That's kind of nice. Now what we need to find is h prime of x. All right, they give us, if you guys remember way back in the beginning of the problem, they give us what h prime of x is. H prime of x is equal to 5, or h of x is equal to 5e to the x minus 9 sine x. So we're just taking the derivative of that. I'm not going to write it down. You guys can look at your problem. The derivative of 5e to the x is 5e to the x. The derivative of negative 9 sine x is negative 9 cosine x. The question asks, what value of x? So the question says, what value of x in that interval does f prime equal h prime? So in other words, we're asking the question, when does 2 equal 5e to the x minus 9 cosine x? So some of you might be thinking, all right, let's do some algebra. No, don't think that. It's a horrible idea. I hate that idea. Get it out of your brains. We have technology. We have these beautiful things called calculators, and we're going to use them. All right, so what you want to do, I actually had it on my calculator, but I'm stupid and just deleted it. Go to your graph. And what we want to do is we want to graph these two lines. So we want to figure out the graph of 2. So you want to graph 2. When is that equal to 5 e to the x minus 9 cosine of x? Put both of those graphs into your calculator. Make sure your window is like a standard window. All right, and your graph's going to look something like this. Now the point is when they're equal. So we want to know when these lines are equal. Well, you can see just off the bat, right? There's at least 1, 2, 3, 4 different spots. Think to yourselves, what spot do we care about? What spot am I looking for? And it's got to be very specific because we want to know what value of x those are equal to on the interval -1 to 2. So we're going to go to second, calculate, and then you're going to go down to intersect. We're going to calculate when those graphs intersect. From -1 to 2, there's only one spot they intersect, and it's right over here, like the farthest right intersection point. So it's going to say first curve, second curve. So you're going to click on enter, enter. It's going to give you a guess, who cares? Click enter one more time, and that's going to be your point. You can see on my calculator that's going to be, which is it going to zoom in? It's really hard, can't tell. But it ends up being 0.622. It's not necessary. I always like to preface when I use my calculator. At least I'm not positive if it's necessary. Give me 1 second. Yeah, I think like you're okay from there. I don't think you need to say use a calculator. I just recommend it. You might as well. And if anything, you could even say use calculator to graph the function. Be as specific as possible. All right, you're not going to lose points for being like specifically saying what you're doing if you have enough time to do so. You'll lose points if you're doing it incorrectly, obviously. But I would definitely like specify use a calculator to get that value. And even if you want to say use calculator to find intersection, found it was at 0.622. To check my work, right, it makes sense. 0.622 is between -1 and 2. I can take that value and plug it back in to my derivative equations, and find that's true. So that's the homework. So hopefully this was helpful to you guys. Please, like I said, any questions you guys have, bring them Monday. I will try to be as thorough as possible as I could with this. Hopefully this was helpful. Let me know. If you guys have any questions over spring break about this, go ahead and email me. I'm fine with that. I'll try to answer as much as I can. Hope you guys are having a great spring break. Hopefully you guys are looking at this and completing this assignment. Remember, your AP exam's the 12th, not that far from now. So please be conscious of that. Thanks for listening. Thanks for participating with me. Hope you guys have a great rest of the week.